Today we are going to learn about mastering cache invalidation techniques. We will explore effective strategies to implement and manage cache invalidation, enhancing your skills in maintaining data consistency and performance in dynamic applications. Welcome to our video on mastering cache invalidation techniques. Cache invalidation is a critical concept in maintaining data consistency and performance in dynamic applications. Today, we will delve into the strategies and techniques that ensure your cache remains an asset rather than a liability. By the end of this video, you will have gained a comprehensive understanding of how to implement and manage cache invalidation effectively, ensuring your applications run smoothly and efficiently. Cache invalidation is often cited as one of the hardest problems in computer science. At its core, it involves ensuring that the cache reflects the most current state of the underlying data. One major challenge is the trade-off between maintaining data consistency and optimizing performance. When caches hold stale data, it can lead to inconsistencies, affecting the user experience and potentially leading to incorrect application behavior. Several strategies, such as cache eviction policies and careful design of cache update mechanisms, are employed to tackle these challenges. Understanding these challenges is crucial for effective cache management. As we explore this topic, keep in mind the delicate balance between cache accuracy and system performance. Stale data occurs when the information in the cache is outdated and does not reflect the current state of the system. This can have significant impacts on applications, particularly those that are heavily dependent on real-time data. Imagine an e-commerce platform where users see outdated prices or availability. Such inconsistencies can lead to customer dissatisfaction and lost sales. Detecting stale data involves mechanisms like versioning or timestamps, which help in verifying the freshness of cache data. Mitigation strategies include implementing robust invalidation policies and leveraging technologies that allow for real-time data updates. The goal is to maintain an accurate and reliable cache that enhances user trust and application reliability. Time to live, TTL, is a crucial strategy in managing cache invalidation. TTL defines the duration for which data should remain in the cache before it is considered stale and removed. By setting appropriate TTL values, you can control the lifespan of cache data, balancing cache freshness and system performance. In environments where data changes frequently, shorter TTLs may be necessary to ensure data consistency. Conversely, in more static environments, longer TTLs can help reduce cache misses and increase efficiency. Implementing TTL effectively requires understanding the data access patterns and the specific needs of your application, ensuring optimal cache performance and reliability. Event-driven cache invalidation represents a proactive approach to maintaining cache accuracy. This technique relies on specific events or triggers as data updates, user actions, or system changes to initiate cache invalidation. By responding to these events, you ensure that the cache remains synchronized with the latest data state. This approach is particularly beneficial in applications requiring real-time data consistency, such as financial systems or collaborative platforms. Implementing event-driven strategies involves setting up listeners or hooks that detect relevant events and automatically update or invalidate cache entries. This results in a more dynamic and responsive caching system, maintaining high performance and data consistency. Versioning is a powerful technique in cache management, offering a systematic way to track changes and ensure data consistency. By associating a version number or identifier with each cache entry, you can easily determine whether the cache data is current. This allows for efficient cache validation and updating processes, minimizing the risk of serving stale data. Versioning is especially useful in distributed systems, where data consistency across multiple nodes is critical. Implementing versioning requires careful planning and integration with your overall data and cache management strategy. Despite challenges such as version conflicts or increased complexity, the benefits of improved accuracy and reliability make versioning an essential tool in advanced cache management.
Cache invalidation becomes significantly more complex in distributed systems due to the need to maintain consistency across multiple nodes or servers. Distributed caches must be synchronized to ensure that all parts of the system reflect the latest data state. This requires strategies such as distributed locking, consensus algorithms, or employing centralized cache managers. The key challenge is balancing consistency with availability and performance, often necessitating trade-offs. Best practices include using technologies like Redis or Memcached, which provide robust tools for managing distributed caches. Understanding the nuances of distributed cache management helps you design systems that are both efficient and reliable, meeting the demands of scale and performance. Achieving cache consistency while maintaining high performance is a classic engineering challenge. Consistent caches ensure data accuracy, but can introduce latency and reduce system throughput. Conversely, optimizing for performance might lead to data inconsistencies, particularly in rapidly changing environments. The solution often involves strategic trade-offs, such as implementing eventual consistency models or using a combination of caching strategies tailored to specific application needs. Understanding these trade-offs is essential for designing efficient systems, as it allows you to prioritize based on the critical requirements of your application, whether they be speed, accuracy, or a combination of both. Minimizing cache misses is vital for maintaining high performance and improving user experience. Cache misses occur when requested data is not found in the cache, leading to time-consuming data retrieval from the primary data source. Techniques to reduce cache misses include optimizing cache size, using predictive algorithms to pre-fetch data, and implementing efficient cache replacement policies. Regularly analyzing cache performance and adjusting strategies based on usage patterns can significantly enhance efficiency. Employing best practices such as monitoring cache hit ratios and adapting to user behavior ensures that your caching system effectively supports your application's needs, providing a seamless and responsive user experience.
In conclusion, mastering cache invalidation techniques is crucial for anyone involved in developing dynamic applications. By understanding challenges, implementing effective strategies like TTL, event-driven invalidation, and versioning, and balancing consistency with performance, you can significantly enhance data consistency and application efficiency. The skills gained today will empower you to design better caching systems, optimize application performance, and provide a more reliable user experience. Continue exploring this topic to further refine your skills, and remember that cache management is an ongoing process of learning and adaptation.